Hi, it's Ms. Young. I am back to talk to you today about how to find the values of trig functions for any angle, even if it's not a special angle on our unit circle. Even if we have no idea of the measurement of the angle, we're still able to find the values of the 6 trig functions. We will use a combination of Pythagorean theorem along with ratio of coordinates based on sine and cosine from the circle itself. So let's get started. In our first example, we are given that -5, 2 represents a point that's on the terminal side of an angle. Now we have to be familiar with the vocabulary. The terminal side is where the angle is measured to. The initial side is where the angle is measured from. So my recommendation would be first to draw a picture of what this angle would look like. So you can draw that with me here. I'm grabbing my ruler just to set up my coordinates. And this is a second quadrant angle. And I know that because x is negative and y is positive. And so if I space out 5 on the x to the left and 2 on the right, then I know that that point that I'm talking about is about there. But what I'm interested in is understanding that that is the terminal side of an angle. So now if I connect this with the origin, I'll get a better idea of the picture and the angle that I'm interested in. So I'm really interested in an angle that would be measured here, where this point isn't necessarily the end of the segment, but this angle could possibly continue on, and I'm just interested in the fact that that point is on the angle, is on the terminal side itself. Now, alone that doesn't seem to give us a whole lot of information, but I do want you to keep in mind what we know from right triangles and what we've learned about the coordinate grid and circles related to the right triangles. I can create a right triangle by dropping a perpendicular from this point down to the x-axis, and now I have a right triangle. Not only that, because we understand reference angles, even though we may not know the coordinates of this point, even if we didn't know that it was -5, 2, we do know that this reference angle being measured with the horizontal here has the same measurements as far as cosine and sine as if I were measuring from the first quadrant. So I can use that to my advantage. So now that I have done that, I can identify different parts of this triangle. For example, I know that the horizontal leg has a measurement of 5. But because it's in the second quadrant, I'm going to make sure I label x as -5. And I know that the vertical component of this triangle has a length of 2 because I had to go up 2 in the y direction in order to get to that point. So I know that x is -5 and I know that y is 2. The only other information I need to help find the 6 trig function values is the measurement of r, which if this was a circle, I need to know the measurement of that circle's radius. Well, because this is a right triangle, I can use Pythagorean theorem. And in using Pythagorean theorem, I know that leg squared, which is x squared, plus the other leg squared, which is y squared, equals the radius squared, which is the hypotenuse squared. And so as I substitute here, -5 squared plus 2 squared equals r squared. Simplifying, I find that r squared is 29, which results in r having a value of the square root of 29. It's going to make your life much simpler if you leave it just as that. Now, I need to find the value of 6 trig functions. I'm going to separate these out according to which ones are related to each other. So let's begin with cosine. Cosine of this angle theta can be found by taking the x-coordinate and dividing it by the radius. And that's because cosine is adjacent over hypotenuse. And so for us, that's -5 over the square root of 29. Now if we rationalize, we'll find that that's -5 square root of 29 over 29. Related to cosine through reciprocal is the secant. Secant of that angle theta is r over x, which would be the square root of 29 over negative 5, and we can just stick the negative in front. The next pair that are related to each other are secant and, sine and cosecant. So sine of theta is y over r. The y-coordinate is 2. R is the square root of 29. Again, simplifying, this becomes 2 root 29 over 29. Cosecant is the reciprocal of sine, which is r over y, and that just results in the square root of 29 over 2. My last combination, tangent and cotangent. Tangent of an angle can be found by taking its y-coordinate and dividing by its x-coordinate. So for us, that is 2 over negative 5, and we can put the negative up top with the 2. So this is negative 2/5. And cotangent is the reciprocal of tangent, x over y, where we take negative 5 and divide it by 2. So the value of our 6 trig functions can be found here, again, organized according to which angles are reciprocals of each other. Our next example doesn't give us coordinates. Instead, it gives us the trig value of the angle itself and tells us the location of the angle. So we're told that theta is located in quadrant 4 and that the tangent of theta is negative 15 over 8. So let's make another diagram. I always recommend that you start with a diagram. This one is a 4th quadrant angle. So I won't use too much of the other quadrants. I'll just use what we need for the 4th quadrant. And I'll actually make the y-axis a bit longer so we can fit in everything that we need. So I have this angle theta, and understanding that tangent is opposite over adjacent, which in terms of x, y, and r results in y over x, I know that I'm looking at a distance of 15 in the y direction, the negative y direction, and a distance of 8 in the positive x direction. So as I start to map that out, if this is 0, I'm going to estimate here negative 5, negative 10, negative 15 for y, and then 5, about 10, and 8 would be maybe right here. And so understanding that theta is measured with the closest x-axis, I'm going to draw in what this angle might look like. So if I had to go down 15 and over 8, I'm about here. And so I would be looking at a triangle that could be created like this. Again, understanding that theta is measured with the closest horizontal axis. And so again, to make some things clear, my y coordinate is negative 15, negative because I'm going in the negative y direction. My x coordinate is positive 8. Once again, I'm missing the r, which is the radius or the hypotenuse of the triangle itself. And so x is 8, y is negative 15. I can find r squared through the Pythagorean theorem. R squared equals x squared plus y squared. Substituting the 8 and the negative 15, and then adding those together after squaring, r squared becomes 289, and the square root of that is 17. Now, if I want to find the 6 trig functions, or the values of those functions, I already have been given tangent, and so we'll find the others similar to the way we did in the last example. Beginning with cosine. Again, cosine can be found as the ratio of the x-coordinate to the y-coordinate. And so in this case, I apologize, say that again, the x-coordinate to the radius, or the r-coordinate. So cosine is 8 over 17. Likewise, secant, which is the reciprocal of cosine, or r over x, is 17 over 8. Next, I will do sine and cosecant. Sine theta is the ratio of y to r. Y is negative 15, r is 17. Cosecant theta is the reciprocal of sine, so the ratio of r to y, where this is 17 over negative 15, and we can stick the negative at the top. Lastly, we were given tangent. Tangent of theta is negative 15 over 8. Again, that's y over x. Cotangent would be the reciprocal of that, which is x over y, 8 over negative 15, and again we can stick the negative at the top. So take a look at those two. You may want to pause the video if you didn't catch all of those examples, or rewind where necessary. And then the last thing I'd like for you to do is to try these two. Very similar to the examples that I gave you in A and B. Negative 5, negative 6 is a point on the terminal side, and in part D you're given that the value of cosecant is 4, and that it is located in quadrant 2. So you want to think about how we find cosecant. One hint for that one is you might want to make 4 a fraction and call it 4 over 1. Check the blog later for answers to these two to make sure that you work on them and get them correct. And don't forget to do your homework and practice for your unit circle skills check in chart form this time. Have a great weekend. Don't forget to have some fun after you do your math, or in between, or before, whenever. Just make sure you have some fun. See you on Monday.